Hello everyone, welcome back to the next video. In this video I will show you how to integrate a C++ library in a native iOS application with Swift. Now some of you might know that there is a feature in Swift 5.9 where you can mix C++ and Swift via Swift interoperability. We won't be looking into that in today's video. We will be still using Objective-C++ as a wrapper. Because like I couldn't figure it out how to directly mix C++ and Swift. I tried watching the WWDC video, but unfortunately I couldn't. But anyways, I don't think Objective-C is that bad. So yeah, let's get started. And here you can see that I have just created a native iOS application. I am using UIKit, but if you want you can use Swift UI as well. Now I have this particular library called FMT. It is like a very simple library for you, mostly used for formatting library. Okay, so we will be using this particular library and we'll see how to integrate this in a native iOS application. So let's get started. Now I have created one practice project for me because it's very difficult for me to remember all the steps. So first what you have to do is you have to install CMake using Homebrew. I have already installed it. You can just do a Google search on how to install Homebrew using CMake. I think it should be brew install CMake, something like that. Next, once that is installed, just make sure you have CMake properly installed. So I can do something like CMake dash dash version, and here it should print our CMake version. So as you can see, I have this. Next we will have to clone our project. So clone this particular project in a separate folder. Don't clone it inside your iOS project itself. So what I'll do is that I'll just go to the cpp folder which I have. It is outside my native iOS project, and I'll quickly run this. So here I'm basically cloning this particular project. So this is the URL for this GitHub project, which is in completely in C++, as you can see. And I'll just do a git clone. Now it will clone for us. Now the next thing which we have to do is basically we have to create an XC framework for this C++ library to be used directly inside our iOS application. So for that now I'm only building for the ARM64 architecture, but if you want to do it for x86 as well, you can follow the similar process. Just instead of ARM64 you have to write x86_64. so use whatever you prefer. Like I would be only testing on a real iOS device, but if you want to test it on simulator, I will let you know the comments as well, commands as well, how to do that. Okay, so here as you can see it has cloned my project and it has created a folder called FMT. I will cd to that particular folder. Then inside that particular folder I will create one directory called build-ios-arm64. You don't have to name this like this, but just for my own sanity I'm naming it like this. Then I will just like go to this particular folder. If you are instead of ARM64 you can also name it as x86-64 if you are building it for that particular architecture. Okay, once you are into that, we just have to run this particular command cmake. I'll just tell you what exactly it does. So cmake dash dc make osx architecture is ARM64, but here instead of, if you want x86-64 you can write that as well. Then this is for the iOS system, and the OSX deployment target I have kept it as level.0, and here we are doing dot dot so that it can get hold of the cmake file which is in fmt folder. So if I show you the fmt folder, here you can see it has this cmake list.txt. so this cmake command requires a cmake list.txt. so here we are basically telling that you just have to go one directory before and you will find your cmake list.txt file. So I will just run this. Now this will take little bit of time, so be patient. So here you can see the build files have been written. Okay, now what I have to do is I just have to run this make command. So if you see my build iOS, here bunch of stuff has been created, and I will just run this make command. Now again this will take little bit of time depending on how big or complex your C++ library is. So again be patient. Once that is done, I will come back. So I'll quickly edit this out and come back once this particular thing is done. Okay, so as you can see my make part was done as well. The next thing is we again have to do cd dot dot. So I will move into the main fmt folder, and then here so suppose if you want to do this particular part for x64, you can use something like this, but you don't have to write arm64 as well. If you want to do both of them simultaneously, you can run something like this. Ignore this command, this is for mac os. Okay, so you can keep like run something like this and just yeah, get x86 as well. And yeah, something like this you will have to make. So this is the entire command which you will have to follow. So here you can see 64, and this is for CDCM. So something like this, like I don't care about x86. So yeah, next we have to create an XC framework. So I'll just copy this and I'll paste it over here, and it will create automatically. So it creates an XC framework for us. So I'll just tell you the command. What basically it does is that, so this is my folder which I had created, right? So make sure you replace it with your own folder name, and inside that it tries to find this .a file which we have, and just output it to an creates an XC framework out of it. Now if I go back to my fmt folder, here you can see there is this XC framework out of this. So all I have to do is that inside my iOS project I just have to drag and drop it. So I'll do that, and here as you can see I'll just click on finish. Make sure all these checkboxes are checked. Once that is done, now to use it we will first have to create some Objective-C wrapper. So firstly create an Objective-C header file. So I will just name it as hello world wrapper, but you can name it whatever you feel like. Make sure whatever you name the header file, same name you are using it for Objective-C++ file as well. So here I will create an hello world wrapper, name it whatever you feel like. Then I'll just right click new file, Objective-C file, click next, click same name, click next, click create, create bridging header, and here I'll just name it as .mm. So it is Objective-C. Okay, next inside bridging header I will just import this hello world wrapper. Again it should be your own name, whatever file name you have given. So for me it is hello world wrapper. Next inside hello world wrapper I have defined one method. So if you see over here, I'll just remove this code and I can write something like this. So here you are saying that define one interface, it is of NS object, and basically I am writing a method called greeting wrapper, and it takes an NS string. Sorry, it returns an NS string. That's it. Now we will have to write the implementation for this inside Objective-C++ file, right? So for that I'll just go to this and I'll copy paste some code again. Okay, and I'll just paste it over here, and here we don't require this, we don't have this. Okay, and we also don't have this. So basically what I'm trying to do over here is that firstly we are importing our header file, then we are importing fmt core. So there are two ways of importing it. I'm not sure which is the right way, but so if you see the documentation for it, it says that import it something like this. So that's what I have done over here, but even if I import it like this, it works as well. And now to use it, you can just use it something like this. Okay, so I've just copy pasted the code, and here you get a string, and here I'm just converting that string to proper NS string format. That's it. Now to call it from your view controller, so I will just go to my view controller, and here I can just call it something like this. So I'll just copy it, go to my view controller, and I'll just paste it over here. So here we are just creating an object of our Objective-C++ file, and here I'm just calling that particular method, and given that the data can be an optional, I'm just printing it to the console. Now again, given that I have built it for ARM64 real device, that's why you can't really run it on simulator. Like if you want, you can just run the other command which I just shown you. Okay, but I don't really care about the simulator or x86. So here you can see, okay, it is running on my iPad, so hopefully it should run. Once like there is no output to show, but what I will show that I'm just doing a console log, right? So once the console log is done, I will show that particular output to you. So I think this will take little bit of time because I have just updated my iPad OS version. So once this is done, I will come back and show you the output. Okay guys, I have managed to run my application on my iPad, which is a real device, or you can run it on an iOS real device as well. And here you can see I'm getting the print statement. The answer is 42, which we had written. Same thing over here. So yeah, that's it. Thank you for watching. Bye.